Welcome back guys to our class 6, that is subnetting. We look at classful IP address subnetting and classless IP subnetting. Under this topic we will cover what we mean by subnetting and some various examples on how we can calculate both classless and classful IP subnetting. So without any further ado, let's see what we have next. Subnetting. What do we mean by subnetting? Subnetting is a practice, it's a practice of dividing a network, a big network, into smaller networks. A practice of dividing a network into subnetworks. Well, this increases routing efficiencies, it enhances security of the network and reduces the size of broadcast domain. Don't worry about broadcast domain, we'll discuss it in the coming classes. As discussed, good security and performance, easy management, less broadcast domains. So they're just one. So under subnetting, we have classful and classless subnetting, of which we are going to discuss in the next slide. Okay, so this is an example of subnetting. As you can see, they are in the same network but different subnets. The network was 135.70.0.0. So with this network we created several subnetworks. This is the first subnet, the second one, and the third. Okay, from this one network, you see, from this IP address we did subnetting to create 3 subnets, which is 135.7.1.0, 135.7.2.0 and 135.70.3.0. So I hope you understand the meaning of subnetting. Subnetting is a practice of dividing a network into smaller subnets, or dividing a whole network into subnets. Okay, and some of the advantages. Okay, so let's see what we have next. An IP address is classified as a classful when its subnet mask is either /8/16/24. Okay, when its subnet mask is those of a class A, B, C. Okay, so if it is a class A IP address, then it's classful when its subnet mask is this one. If it is class B IP address, it's classified under classful IP address when its subnet mask is this one. If it is class C address, it's classified under classful IP address when its subnet mask is this one. They are always represented with a notation of like class C's notation of /24, class B's /16, then class A's /8. So the method of splitting classful or classless network into smaller subnets, it's called a classful or classless subnetting. The subnet will have the same size. Don't worry about this one, we are going to calculate in the next class and see what we mean by here. Determined by the next maximum number of hosts per subnet. A subnet mask is used to configure the subnets. Okay, so the subnet mask tells us which part of the IP address is a network portion and which part is the host portion. Remember this point. what is a subnet mask? A subnet mask tells us which part of IP address is the network portion or the host portion. For example, a class B subnet mask is 255 dot 255.0 okay, dot 0. Okay, so this is the subnet mask. This subnet mask will tell us which portion of the IP address is the network part and which portion of the IP address is a host part. Suppose the IP address was 152.10.2.1. So subnet mask will tell us the first two parts are for network portion or network ID, and the last two parts are for host ID. Okay, we use IP address and subnet mask to do networking. So we'll use this IP address and the subnet mask to do subnetting. In subnetting, there is something very important that you have to take note: the subnet mask and block size. Any subnet mask that has its last octet within a range of 0 to 128 has a block size of 128. Okay, any subnet mask, its last octet ranging from 129 to 192 has a block size of 64. Any subnet mask having its last octet ranging from 193 to 224 has a block size of 32. Okay, so don't worry about this subnet mask block size. We are going to explain it deeply in the next slide. So let's see example of Classful subnetting. So there is a problem that you have to solve here. Given a network of this one and a subnet of this one, find network ID, first and last valid host ID, and a broadcast ID. Looking at this network and a subnet mask, this clearly tells us that this is a class C IP address, because the subnet shows that the first 3 octets are for the network portion, but the last octet is for the host ID, portion or ID. Okay, so let's solve this problem. This is the network that I have been given. This is the subnet mask. Considering this is a class C IP address, hence subnetting will occur on the 4th octet. Subnetting normally occurs on the host portion. Okay, subnetting occurs on the host portion. The 4th octet is 0. Okay, so let's go back to our table, subnet mask block size table. Okay, so 0 falls within which range? 0 falls within a range of 128, 0 to 128. So the block size is 128. So this is the block size that we will be used to move. We will use to move from one subnet to another. Understand this point. And after this class, you have to go for further researches, because subnetting is very wide, and what I have included here is just a simple case. There are more complicated cases. So 0 falls within a range of 0 to 128 subnet mask, having a block size of 128. So this 128 is what we will use to move from one subnet to another. Okay, therefore, looking at the subnet mask and the block size table, 0 falls within a range of 128 block. So The block size of subnet mask 128 is 128. Okay, therefore we will have two subnets. Okay, from 0 to 127. You know, from 0 to 127 is like 128, because you will start counting from 0, so they are 128. Then another one from 128 to 255. You start counting from 128. This one is also 128. Now that's where the block size comes in. The block size tells us how to jump from one subnet to another. Okay, so let's solve this question. In the first subnet, having a range of 0 to 127, the network ID will be 192.168.10. We take this value and put it here. So the first valid host ID will be the next value. So we will start assigning host devices from this IP address. The first host device will take .1, 0, then 1. 0 is network ID. You don't assign any host device to this IP address. Okay. The last valid host ID will be the second value. The second last value. The second last value from this point is 126. Then this one is the broadcast ID. Kindly understand. The broadcast ID will take the last value, as you can see, 127. So in the second subnet, the second subnet falls within a range of 128 to 255. Okay. Network ID will take the first value. The first valid ID will take the second value, which is 129. Okay. The last valid host ID will take the second last value, which is 254. Then the broadcast will take the very last value, which is 255. So I hope you have understood this simple concept. The key to this problem solving is this table, subnet mask block size table, and this was a classful IP address, class C. Let's see another problem so that you can solve and you understand much about it. Classless subnetting. Given a network of this one and a subnet mask of this one, we have to find the network ID, first and last valid host ID, and a broadcast ID. This is a class C IP address, but this subnet mask tells us that it can be a classless IP address, because a classful IP address under class C, the last octet should be 0. But when it has some values more than 0, it tells us that the network portion has borrowed some bit on the host part. So we classify it as a classless IP address. So this, then subnet mask is this one. Considering this is a classless IP, hence subnetting occurs on the fourth octet. The fourth octet contains a value of 192. Okay, as you can see. Then, referring to our block size subnet mask table, 192 has a block size of 64. This is very direct. 192 has a block size of 64. So this block size will tell us how to jump from one subnet to another. So the block size is 64. And how many subnets are found here? So the first subnet will be 0 to 63, because we start from counting from 0 to 63. 0 to 63 is 64, satisfying this block size. Okay, then the next subnet will be 64 to 127. The range here is 64, 64, 64, 64 until you reach 255. So we have how many subnets here? 4 subnets. Okay, so let's solve this question. In the first subnet, the network ID will be, we take just this first value and place here. Then the first valid host ID, we take the second value and insert here. The last valid IP address, we take the second last value, then insert here, which is 62. Then the broadcast ID, we just take the last value. Okay, the same way we did the earlier. The same case here. Network ID will take the first value, the first valid will take the second value, and the last valid host ID will take the second last value, which is 126. Then the broadcast ID will take the last value. So we do the same to these cases until we reach the broadcast of 255. Broadcast of this one. Okay, understood? Kindly go for further researches. Subnetting is very wide. This is a very simple case that I have presented here. Okay, alright, let's see the last example. The alternative method of solving subnetting problems. Here we are going to use an alternative method. So if you find that this method is a little bit so boring, you can take this method, and at the end of this problem we shall have achieved the same result. Okay, alright, so we have been told to find the total number of subnets or subnetworks and the hosts per subnet. Okay, let's see. Sorry, our network is this one and the subnet mask is this one. Using the conversion table here, the binary decimal conversion table, we convert this subnet mask into binary. It's the subnet mask that helps us to do subnetting. So you have to convert it to binary. So 255 always covers all these 1, 2, 3, 4, 5, 6, 7, 8. So 255, 8 bits consisting of ones. Then 192. 192 will come here. 192 falls here. 128. Then it comes here 64. When you add them, 192. Okay. Then the remaining is 0, 0, 0, 0, 0, 0. Okay. So these are the borrowed bits. The ones bits represent the network. Okay, and the zeros are the host portion. Okay, network bits are represented by ones and the host bits are represented by zeros. Okay, considering the binary values above, the borrowed networks are 2, as we have already discussed earlier. The borrowed bits are 2. The host bits are 6. These remaining 1, 2, 3, 4, 5, 6. So to find the total number of subnets, we are going to use a formula of 2 raised to n, where n is the number of the borrowed bits. The borrowed bits are 2. Okay, 1, 2. Then the total number of subnets are 4. Okay, total number of hosts per subnet, we are going to use a formula of 2n minus 2, which is 2. N is the number of the host bits, which are 6 minus 2, get 62. This is the same case as here. We said how many total number of subnets do we have? 4. So let's see. We have 1, 2, 3, 4. Okay, you can use the two methods. The one that you find very easier for you, kindly use it. And for subnetting is very wide. I've been saying this all along. Kindly go for further researches to find some alternative methods and to find more challenging solutions, to find more challenging problems so that you can solve for your practices. Okay? Alright, so let's see what we have next. Okay, that's the end of today's class. Let's see you in the next class. Bye.